And what about the pi bonds, though? So pi bonds are different than sigma bonds. If a sigma bond looks like this, the direct overlap of orbitals, here I've got SPs overlapping to form a sigma bond. Pi bonds are formed by perpendicular overlap of p orbitals. So the only way you can get a pi bond is by the overlap of adjacent parallel p orbitals. So my choices are this. Here's one p, here's an adjacent parallel p. These guys overlap, that's a pi bond. I could also have them sort of going into the page, right? That'd be a p and a p. If those guys overlap, that's also a pi bond. So pi bonds are formed by the overlap of adjacent parallel, formed by perpendicular over, oh no, tragic, that should be parallel, shouldn't it? And the distribution of the electrons then is above and below, and we'll see some better pictures for that. So if you overlap p orbitals here like this, when you put the overlap together, it kind of looks like that. So there's electron density above and below. That's one pi bond. All right, let's see this in action. Maybe. Hold on. Here we go. All right, so let's talk about sp2 hybridized carbons first. So if we look at the ground state electron configuration, we're going to be 1s2, 2s2, 2p2. All right, we're interested in the valence, not the core. So here's 2s, we have 2 electrons, and then 1 electron each in 2 p orbitals. The first thing we're going to do, just to make things simpler, is we're going to promote electrons up. So we're not ground state anymore, but every orbital is going to have its own electron. So this s has got an electron, each of these p's has its own electron. Now, to make sp2 hybridized orbitals, what do I mix? An s and 2 p's, like this. So those guys then become 3 equivalent sp2 hybridized orbitals. What's left over? A p orbital is left, right? That's what we're going to use to form pi bonds. So here, this is sp2 hybridized, right? It's kind of the parallel picture I draw. These are the adjacent parallel p orbitals. Those guys are going to overlap to form a pi bond. We'll talk about sp in a second. All right, now I just drew this, but again, going through it again, what's the hybridization on carbon? How many things are around it, right? Sigma bonds and lone pairs, there are 3. So we know it must be sp2 hybridized. So if I draw that, I'll switch to black pen. I'm going to draw, here's carbon in the center. He'll have 3 equivalent sp2 hybridized orbitals around him. This guy's the same. All right, if I'm drawing this, I draw it like this. Right, I've shown 3 sp2 hybridized orbitals. What have I drawn right here, where the sp2s have overlapped? That is a sigma bond. All right, what we said was if you take an s and 3 p's, you use 2 p's to make 3 equivalent sp2 hybridized orbitals, you still have a p orbital left. That's this guy right here. So he's perpendicular to the plane of the sp2 hybridized orbitals. But what we have, if we have adjacent carbons like this, is these guys are now parallel and adjacent. They can overlap, forming a pi bond. If I was drawing it here, and it's kind of hard to draw because they're so far away, you want to draw this shape, but it doesn't overlap very well. To do it better, you probably have to draw some crazy thing like this. It just doesn't look as good. So I'll show you some better pictures, but this is how I draw it. So I would say these overlap, and that's a pi bond. All right, looking from the top, just to get, so you can keep your bearings. If I look down, straight down on this picture, I get this. So here's carbon, here's my 3 equivalent sp2 hybridized orbitals. Where are my p orbitals in this picture? Here they are here. All right, so if I tip this guy, they must be straight up and down into the page like this. So these are the shapes we're going to see. This explains then the sigma bonds and the pi bonds in this molecule and sp2 hybridized atoms. All right. So this is drawn. This is the same thing, just another picture, just another way to look at it. What color bonds, what kind of color orbitals represent sp2 hybridized orbitals this time? It's the yellow. All right. Oh, it's a tragedy. I'm going back to black pen. Okay, so that is sp2, sp2, sp2. What have we shown here? Where this 1s overlaps with an sp2, that's a sigma bond. Right, here we have another HC bond between a 1s and an sp2 hybridized orbital. What happens when these sp2 hybridized orbitals overlap? We get a sigma bond between the carbons, right? So we explained all the sigma bonds in this molecule, ethylene. What we have to do is explain the pi. And what we know is we have parallel p orbitals here and here. Those are going to overlap. And so this is a better picture of that overlap. This is kind of what it's going to look like. And remember, even though we have electron density above and below, that's just one pi bond. All right. Again, if I finish this one out, I'd put my adjacent p orbitals here and here, and I have a pi bond there. All right. So these are all the different ways we can draw these things. So one more time. So what do we see here? This is the pi bond, right? The electron density above and below the axis of the bond is a pi bond. What happens? The electron density here is between the atoms. That would be the sigma bond.